But essentially, this is the basic idea, okay? And so what happens is you can make different kinds of activation functions. So remember, we have all of our inputs, and we have we take all those inputs and combine them in some way. And if you remember back about 25 slides ago, there was like that equation, right? So we were like multiplying and summing things together, based on those vectors. And it's kind of the same idea, but it says, what function do we transform? So I did a crosswise multiply in the other one, but this is a linear activation, so it just says we just sum up. It's the same kind of thing. We just sum up and say we find out what, we sum up all of our x's, and then we activate it this much, right? We sum up all of our x's and we activate it that much. Linear activation is very simple. We can do crazier, threshold activation. So it's activates only zeros or ones, right? It's binary. But the idea would be is that once you pass a certain threshold, you're always on, right? And if you don't get to that threshold, you're just totally off. And then you can do something that's a sigmoid activation, which is more of it's an S shape, but essentially it's very steep at 0, and then it tapers off as it goes off to infinity, and never gets to 1. All right, so you can't see it. Can you see it? Oh, you can't see it. Sweet. All right, so there's a sigmoid. So you get the idea of it goes from 0 to 1, but it never quite gets to 1 as it goes to infinity. All right, so for theoretical app, most neural networks use this these days. No, most traditional neural networks use this these days. There are other activation functions. All right, so anyway, what we do is we take these neurons and we put them together into layers. So the layers in this one are these orange circles. This blue circle is our input. So we're going to take our input vector and we throw it at all these neurons. But we saw a picture of this, and this looks pretty familiar. But the fancy part about neural networks is we put them together into multiple layers. Okay, so we'll have something like the input, and then we'll have some kind of layer in the middle, and then some kind of output layer, and we can make these as wide as we want. Ones that are in the middle are called hidden layers. And you can do crazier stuff like this, right? And so making these look like this, is kind of a black art, okay? And nobody really knows. Well, we'll get into that later. But I mean, nobody really knew, how to make these neural networks look good. How many neurons need to be in each layer? How many layers do we need? These are all questions that is just kind of mess with it and see what happens. All right. So anyway, let's talk about what we're going to actually do, and here comes some math. I'm sorry, but we're going to do this real quick. So say you have two inputs, and you have your activation function, and you're going to have an output. So we're going to talk about this, zoom in a little more to the math, and we're going to have these weights that I was talking about, which is how strongly do the neurons behind you activate the neuron, or influence this neuron, and then we have this kind of idea where we put them through